thus have our part 2 problem under heat transfer by convection of thermodynamics and heat transfer. For part 2 problem, let us determine the total rate of heat transfer through convection. In a given scenario, a person is standing in a breezy room which current temperature is at 24 degrees Celsius. Given and determine value for the rate of convection heat transfer to be 7 watts per unit. To be 7 watts per unit surface area per unit temperature. We are tasked to determine the rate of convection heat transfer from the person to the air in the room. The total rate of heat transfer from a person by both convection and radiation to the surrounding air and surfaces at specified temperatures is to be determined. So let's assume steady operation condition exists, and that the person is completely surrounded by the interior surfaces of the room. Let us also assume that the surrounding surfaces are at the same temperature as the air in the room, and that heat conduction to the floor through the feet is negligible. The properties that we're going to use is the emissivity of a person, that is equivalent to 0.95. The heat transfer between the person and the air in the room will be by convection instead of conduction, since it is conceivable that the air in the vicinity of the skin or clothing will warm up and rise as a result of heat transfer from the body, initiating natural convection currents. It appears that the experimentally determined value for the rate of convection heat transfer in this case is 7 watts per unit surface area. Per unit temperature differences, whether in Kelvin or degrees Celsius, between the person and the air away from the person. Thus, the rate of convection heat transfer from the person to the air in the room is this. So we have the rate of convection is equivalent to its coefficient multiplied to its surface area multiplied to its differences in temperature. So the emissivity of the person is 0.95 multiplied to 7 watts per square meter Kelvin multiplied to its surface area, that's 1.5 square meter, and we have here a temperature at 31 degrees Celsius and at 24 degrees Celsius converted into Kelvin. We now have the rate of convection heat transfer from the person to the air in the room to be 61.40 watts. So that's it for our second problem involving heat transfer by convection. Thank you so much for listening, everyone, and that's it for today. See you.